Okay, in the previous episode, we talked about the static calculation. So we just gave these results. But the next thing we want to know is whether or not we can find the static equilibrium. We already mentioned that the mass of the ship is around 5,000 Newton and that we have 17,000 Newton lift in this case. So it will move higher. Something which is very important, check before you do the static equilibrium, this Newton-Raphson algorithm, is checking if whether or not in the situation you have enough lift generated to keep the mass outside of water. If this is not the case, either you need to put the boat deeper into the water and look whether or not it's possible to generate this amount of lift, or you need to increase your speed, maybe change your trim. More positive trim will generate more lift if it's still possible with your moment around the y-axis. But in this case, everything looks good. So we start this static equilibrium equation. Again, you can also do this using the free surface method, but it will take a lot more time. So for this episode, for this tutorial, we'll do it without. So again, we'll start this. This can, of course, again, take a couple of minutes, but we'll skip right to the solution. Okay, here we are again. So we just did the static equilibrium equation. So we let the Newton-Raphson algorithm find a new equilibrium position. So we see now that the boat is moved higher out of the water. So we got an elevation which is higher. Also, the trim angle has changed. It came from 1 degree, it's now 0.2 degrees. So not a really big change, but it still has an effect on it. And what we see is that, well, the current state is at an approximate equilibrium state. So it's nearly zero, the forces in the z direction, it's 17 Newton, which is 7 kilograms. On a total mass of, well, it's still 7 kilograms, of course, but on a total mass of 500 kilograms, well, this is next to nothing. This is next to nothing, yes. Well, then the same thing is for the moment around the y-axis. It's only 9 Newton meters, also quite small. You can let it run another time to get it even smaller, but for our purpose, for our application, this is okay. But once we have this, it only leads us for the next step, where we want to calculate the longitudinal stability analysis, but that's for the next episode.